Let me actually capture what it takes for us to deploy our API gateway. So we got an email from AWS the other day that said our certificate had expired. Oh, sorry, it did not say the certificate expired. It just said that we were not reporting usage to AWS, which we have to do every so often. So when someone subscribes to our APIs on AWS Marketplace and they start using it, integrating it, and they start leveraging our endpoints, every time they make a request, we have a charge, correct? So it's $2 for the current pricing is abysmally low, but regardless, it's $2 for every 1,000 requests. We need to report that usage to AWS for AWS to actually pay us, right? For the customer would pay AWS and they would have to issue the, make the payment to us. But for that to happen, the usage records need to be submitted as it states here within the 6-hour window of the request being made. So if someone made a request at 6:05 p.m., within the 6-hour window from that point onwards, that request that request would need to be reported to AWS via the batch metering integration that we have on one of our lambdas, right? We have two lambdas and that deal with the API side of things. And the second of those lambdas, not the request transformer, but the batch metering lambda, deals with reporting usage. And we have it configured to do it every so often. It's not like 6 hours. I believe we have it every, if you go look at it, it says one rate 180 minutes. Actually, this is the actual syntax. Wait, hang on, that is not the syntax. I'm going to search for 180, and I know it's in a file where, yep, here. So it's in template YAML 2. This file basically, we have two YAML templates, SAM templates, 1 and 2. Again, before I go to that detail here, the rate here, it says this exact syntax is important. I mean, there cannot be an extra space or anything else. As weird as it is, this is how it needs to be. The expression for it to be reported every 3 hours. Now we have this, which we comment and uncomment. We swap this out when we test it because we don't want to wait 3 hours when we're doing the testing. So we redeploy the lambdas by setting it to 2 minutes. So we know the reporting happens super frequently, like every 2 minutes. So we know what activity is going on. And once that is done, we flip it, swap it back to 180 before we deploy to production. We never deploy 2 minutes to production. We deploy that to the lower environments essentially. And we'd have 3 environments: dev, staging, and production on AWS. So if we go to API gateway, to APIs, we have pitch proxy, API, dev, prod, and staging. They're meant to be identical with 3 environments, so to speak. But this is the way that AWS does not provide a notion of environments, at least not organically. So we create 3 APIs and name them in such a way, with the prefix being the environment name, so we know which API we are actually dealing with. And for each of those, the whole 9 yards has to be the dependency that's related to that particular environment. If it's dev, everything that touches should be dev. If it's staging, everything that it touches should be staging, because we don't want to mix and match because it becomes confusing. Now, sometimes you may want to save some costs, so we might use the same database for dev and staging, obviously not for production, but ideally, each of those environments are as separate from each other as possible. Now we have 2 template files here quickly because we've broken it down that way. So if I go to template 1, if I go to do the structure, you can see all the details of that particular template. If I go to template 2, you'll see there's a lot more to it. So the difference, remember here, is template 2 has blobber. We don't use blobber anymore, but it's okay. We need to yank that and clean that up. We have the difference, as you can see here, it's batch metering and blobber, and maybe there is rapid API, Snowpal, and maybe Open API. Let's see that. Yep, none of those are here. So template 2 is the superset. It basically has the plans. When we used to use blobber, which we still have our APIs configured on Open API Hub, even though we don't look at it. We've hardly looked at it in the recent past. Rapid API has it as well. So people can consume APIs from one of those 3 places. The blobber is not there. So for other 2 places are Open API Hub and then the Rapid API. So this second template has those details and those plans. And similarly for Snowpal API and API Snowpal plan key, which is when we are reaching out to the gateway when the Snowpile API makes some request to the gateway to provision a new subscription and whatnot, we don't want to pay ourselves, correct? It's not like we are paying per request. So to skip that, we have a usage plan tied to the Snowpile API that does not charge us anything, obviously, right? But for the other ones, there is a charge for all the other API hubs. But this one, it's meant for us. It's internal, so there's no charge for when the request actually comes through. So those are the two templates. And in terms of the actual command to deploy, if I go here, let me do grep -I deploy. We've written some convenient scripts. So we have a deploy.sh script. So if we go to deploy, so we can look through this in detail, but some of the values we need to pass is there's three substitution variables. The first one is the environment. So dev is default. If it's dev, you don't need to pass anything, but it's incremental. So if you're changing the other two, you'll have to pass this as well. But in this case, when you're deploying the prod, you do a deploy.sh in the directory that it is in. The directory that it is in is the SAM API gateway directory. You'd say prod or dev or staging, depending on where you want intending to deploy to. And here, if you want to run all templates, the default is false. If you want to run all templates 1 and 2, you would say true. Now the thing is, you could ask, why do I have to run template 1 at all if I'm doing 2? I need to remember this, but for when you're provisioning a new environment, you have to run template 1 for sure. Maybe you don't. I'm trying to recollect. Maybe we've made a lot of changes to these templates along the way. We'll have to be 100% sure. We'll have to create a new environment, a fourth one, even if it's only for test purposes, and try to just run the second template and see what happens. See if it needs to be incremental. I have a reason that there is some method to this madness, and it needs to be incremental the way we created it. I have to look up our documentation to jog my memory. So if I create a new environment, I would certainly start with 1 and then do 2, and that's surely going to work. But to play the devil's advocate, I might just start with 2 and not do the 1, deploy 1 at all, and see if it works or if it does not work. Right? That's what I would do. Now, going back to deploy, that's the second thing. And in this case, for the certificate problem, I only had to deploy the second because all these environments are already set up and we're deploying to dev, then staging, then prod. So I only did 2. So it was deploy.sh prod or environment dev space 2 space run step. The run step, deploy environment and then the boolean, and then the last one was 2, which is run step 2. Right? If you're running all templates and the third one obviously doesn't mean anything, you don't pass it. But if you're not running all templates, you want to specify which template it is, whether it's 1 or 2. And I think the way the script works is it has a template.yaml as a name, and it does a dot template.yaml dot as the prefix, and then based on the number you pass, it's going to make concatenate that and use that particular template to actually do the deployment. Now you could do a SAM deployment, and it actually failed because of some other reasons. Now AWS has made some changes recently or in the recent past where they've gone for TypeScript to version AWS SDK v3 for TypeScript. So version 2 did things quite differently in many different scenarios, and version 3 does it very differently. Now we use something called, we have a couple of lambdas, as I mentioned, right? So our lambda is here. We have 2 lambdas, and then to get to the problem, we would go to like request transformer dev, or actually we would go to CloudWatch, which we can go to monitor from here to CloudWatch logs, or we can go to CloudWatch by searching for CloudWatch and going to the log groups, picking the actual environment and the lambda, and then looking at the most recent one. I usually delete everything and then look at the most recent one on the lower environment. That way you don't have to wade through multiple logs, or if there's, we need to clean this up because there's a lot of pending logs here. But that's the quickest way to, once you reproduce a problem. If you're debugging a problem in production, then you go look up an existing log, map it, find the timestamp, map that to the logs timestamp, and try to find where that error happened or where that interaction or the transaction happened for you to try and debug the problem. But if you're reproducing the problem in a lower environment, then just delete it, have it generate a new log stream. That way it's the quickest and easiest way to do it essentially. So you look at the problem. Here is where we saw that the certificate had expired, and then to figure out what the expiration was, we started by actually going to API gateway, and as it turned out, there is a notion of a certificate here, a client certificate. And if you go to the client certificate, this had expired, but that even after generating a new certificate, nothing happened. But then we figured this certificate is for us to verify that the requests, any requests we entertain in the gateway originate, essentially requests to our HTTP integrations are actually originating from the API gateway. That way, if it's not coming from the gateway, we reject the request straight away. That's something we can check in the code that, to verify the authenticity of, the request by checking the header and to see that if there's a cert, if the cert is valid. But that had nothing to do with the problem, because we are reporting usage to batch metering Lambda, which is our second Lambda here. If I go to Lambdas, the batch metering is the batch metering dev. This is the Lambda we used to report usage every so often to AWS. And that was failing because we make the request, and since the certificate was invalid, it did not go through. And as it turns out, the certificate that we needed to fix was in AWS certificate manager certificate. I think it's ACM. Yep, this one. The certificate manager. There is a cert here that's a wildcard cert for start@snowpal.com. This had expired, and that was a problem. As it turns, this is an important cert because this cert is what we use, and that had to be imported again. Now we'll come to the details here as to what needed to happen during the import. But once we imported the certificate from GoDaddy, and when we did it the right way, it was not the right way when we did it initially because of some other nuances of AWS. Let me see if I'm still recording. Yes, I am. So coming back here, this certificate, we imported the certificate, and then after doing that, we went to AWS console and we have custom domains like cnames define, so that when production users use our APIs, they don't actually have to, use the CloudFront. We use CloudFront. They don't have to use the CloudFront URL, which is one thing. For starters, it's it's internal. It's not pretty, and it's not our URL, right? So we have a CNAME defined on DN simple. That CNAME gateway.snowpal.com points to this CloudFront. So if I go to DN simple, and then if I go to DNS, and if I go to manage DNS records and I go to gateway.snowpal.com, you'll see that it points to this CloudFront. It's a CNAME pointing to this D11's CloudFront. That's the production URL. We have the same thing for the lower environments as well. Now that custom domain, that CNAME, for once we import the new certificate, we need to edit the cert here and reassociate the new certificate. If we deleted the old one and updated it, or the first option was to actually not even delete it, but to go here and you can edit that cert and re-import it, right? I'll come back to these three sections here. If you did that, then you don't have to make any changes because it's the exact same cert. But if you import a new cert, then the ID is different, the ARN is different. You will have to do the association. We did that, we saved the changes, so it picked up the new cert that's valid, not expired, but the exception did not go away, and that's what threw us in a loop, and we were debugging a number of other things that ended up being unrelated. The cert, again, going back to how we imported the cert, back here, there's three pieces to the cert puzzle. There's a body, the PEM file. So we get our certs from GoDaddy from the beginning of time. You go pick the Apache download option, download the cert. It's a zip file. You unzip it. There's three files. The PEM file's content goes here. The private key is not something that comes from GoDaddy. It's a private key that we have internally. So we need to. It is important that we have the key and we've saved it, so we know we need to use it. So unless that key changes, we have to use that private key, which again does not come from GoDaddy. It's something we have internally. It needs to map with the certificate. Otherwise, it's not going to work. It's going to say the cert is invalid. So the PEM body comes from GoDaddy. The private key is something we have internally. And then the certificate chain is optional, as it says here. So we didn't need to, we hadn't updated anything, and we hadn't done it in the past. If memory serves me right. But as it turns out, that caused a problem. We didn't know that because it's optional, so we didn't need to do it. So what happened was, even when all of this was done, we created the new certificate or update, re-imported the cert into the existing one, associated that with the custom domain. Things did not work. It kept failing. There were no errors here, but it kept failing. So what we did was we went here and tried to create a new custom domain just to debug the problem. And now there are two types of endpoints that AWS supports: a regional endpoint type and an edge endpoint type. We use edge. Now, for the differences between edge and regional, you should just look it up. We use edge for a number of reasons, and that's what our architecture depends upon. So I try to create a new public endpoint using the edge type and that new cert, and it failed. The error was the certificate was not issued by a valid certificate authority, but that's not true because GoDaddy is legit, and we've used GoDaddy. And as I found out, AWS products might, some AWS products might recognize certain providers of SSL certs as valid, but not all the providers. So it is likely, it's possible, as I understood it, that GoDaddy may not have been supported certification authority for what we're using here on the gateway. That's what I'm being told. But that is actually not the case. I know it because that's what we've used in the past. Unless something ended up changing, now they don't have that as a valid authority, which is always possible. So that is a possibility. But if that were to be the case, when we re-imported the cert, it should have failed. And creating a regional endpoint, which went through fine, should have failed, but that didn't fail. The only thing that failed was creating an edge endpoint. And the error it threw was that it's not a valid cert. So something is amiss. But as I dug deeper, we figured that the edge endpoint uses AWS CloudFront. Sure, we know that. I mean, we use that, I should say. I didn't know that it was specific to the edge endpoint, and the regional endpoints did not use CloudFront. I didn't know that. But the edge endpoints use CloudFront, and as it turns out, the CloudFront rejected the cert, even though some other AWS products were okay with the way we had imported the cert here. CloudFront failed. It's because, and again, there's a page I can try to find a link to where you can analyze the cert and the quality of the certificate. Calling GoDaddy, they confirmed that the cert was good. When we go to the browser and go look at the certificate on our pages where we use the same certificate in different forms on our other products, the certificate showed up as valid. The connection was secure. There were no issues. It had not expired. And when we made a curl or a wget request from our machines to say gateway.snowpal.com, our gateway server, the production and the other and lower environments, there were no errors. But when we made that exact same request from, say, our Salesforce and Heroku servers, it failed with an error message that I don't recall. I can find that here, which told there was a discrepancy which caused more issues because we try to reproduce a problem locally and in a seamless manner, something that's quickly reproducible, so we can test changes incrementally and as many times as possible. And since it didn't fail from our systems, we thought the cert was good, but it was not, because it failed from the actual servers that we are leveraging, even for our production systems and the lower environments as well. So that was a problem. So long story short, CloudFront did not like the certificate. And when you looked at this, analyze the certificate, I believe it needs to have multiple depths, like 3 levels, in this case at least, for the chain part of the certificate. But there was only one. It only had 0, not depth 0, 1, and 2 as was expected. So the certificate chain, even though it's optional, it's not optional for CloudFront. That PEM content needed to be added here. Now, where does this come from? It again depends on the provider, but in our case, one of the files after we unzip the GoDaddy cert is actually, I believe, a CRD file, which is the lengthiest of the 3 files, with a lot of different sections of snippets with a start and end that looks like a chain, because it is in fact a chain. So that content needs to go in here. You put that content here. Now you have all 3 sections filled out and you import. You're not going to see any difference because the import goes through fine like it did earlier. And then you come back to the CNAME part, right? Wherever we had the CNAME association. Let me go to API gateway. Well, we went to the CNAME and let me go there quickly. The custom domain names in here. We edit this, and we need to import that cert with the chain here. But remember, we had added a regional endpoint, and that went through, but not the edge endpoint. So what you can actually do is AWS has a way to migrate a regional endpoint type to an edge endpoint, which was failing earlier with the exact same error that said the cert is not issued by valid authority. Before, we had imported the cert with the certificate chain. But now, after we did basically with the certificate chain, the migration went through. Again, that's the slowest, smallest reproducible test case. It's quick enough for us to tell. So you don't even have to go through our entire reproducing the problem process just as yet, because we isolated that to something else that failed someplace else. Now that goes through, which means if the goodness is going to trickle down to our consumption of the certificate, if you know what I mean. So that's important to have a reproducible test case, right? A small reproducible test case. Now the migration worked, and then even outside of that, you could go now create a new custom domain directly using Edge and optimize, which was failing earlier. That didn't fail either. So which meant we appease the needs of AWS CloudFront from a certification, from a SSL standpoint. That was what needed to happen. Once it happened and we redeployed, sam deploy deploy a script that we have, the deploy script essentially does, if you go to the actual deploy script and check this out, it uses sam deploy, the stack name, and a number of variable substitutions and replaces the environment. But what we do is we basically have a command that facilitates this, so to speak, right? A script that makes this easy for us to consume. So we deployed this to the lower environment after making it 2 minutes, not 180 minutes. Remember the mention earlier where we had to change this to 2 minutes. So that way we could test it, right? Not wait like a whole 3 hours before we tested the reporting of the usage. And usage was sure enough reported, and that took care of the problem essentially. Now that is the AWS part of what needed to happen. But we have a way for us to sort of, let me close these windows here so they don't come in the way now. Okay. Now going back, I think I mentioned, oh yeah, the SDK, AWS SDK had changed. I think I mentioned that for TypeScript version 3. So we had to make some code changes as well to support that, because one of the things actually I forgot to include this. Our lambdas use layers, right? So AWS we use, so let me pull one of the lambdas up here. Okay, let me go to request transformer dev, and if I go to layers, so layer is essentially a set of dependencies that you can add any number of layers to support your lambdas. You can look up layers, but what we do is all of our npm modules that are in packaged or JSON, we actually add them as layers. Now, there's this size restrictions of layers. You can add a layer, and if it's too big, it's going to complain. You can pick existing layers if you want to consume them, but we have a custom layer. If that zip file is too big, we basically take our node modules, create our layer, and there's a sequence of steps that we do to create the layer. I think it's probably in, is it in this file? Yeah. Here are some nodes that we have. So, let's take the request, doesn't matter, the metering request. So after we do a yarn install under the metering request directory, which is if you go here and if you go to metering request, right, we do a yarn install, it's going to, look up the package, look up package.json and install all the node module dependencies. Those node modules we do not include as part of the Lambda depends on it, but the actual node modules are not deployed as part of the Lambda, because for a number of reasons. One is you want to keep that separated and clean to adding the dependencies, because you can have any number of dependencies and the size restrictions with what you can upload with lambdas and whatnot. So again, long story short, we have layers for each of our lambdas, and sometimes multiple layers, but in this case I believe it's a single layer where we package all of the dependencies. Now prior to AWS SDK version 3, we did not have to include the AWS SDK because that's part of the AWS the Lambda engine, so you don't need to include it. But our code has the dependency on package.json. So what we do is we delete it, because including that makes the zip file really big. And if the zip file is over a certain size, you're expected to put that on S3 and reference it on the layers. You cannot upload it directly when you go to add a layer. But even if you did reference it, the unzipped version needs to be less than a certain size. So if you look up AWS unzipped, AWS layer unzipped file is bigger than some error message. Yeah, see, unzipped file size must be smaller than, what is it, 200 and whatever this is. Yep, that many bytes, right? So that's the size. But when you include AWS SDK in your layer, and you generate the layers using this sequence of the step here, which is we have a different layers directory, and we basically zip it, right? We zip the node modules. See, we go to layers, and then we copy the node modules from where it was generated on under request transformer, and the other one batch metering, copy it over to the layers directory, and then zip it. But before we zip it, we have to remove the AWS SDK, because if we don't do that, the size would become too big, and you cannot add the layer, and it's going to fail. So we used to take care of that earlier, because we didn't need it. We would delete it because it was part of the AWS Lambda engine. But with SDK version 3, they made some changes where they've made it, because with the AWS SDK, the problem was that you add that node module, and it's big because it's all inclusive, and now you don't need all of you don't need most of what is part of that AWS SDK npm. So if you go to, like, say, npm JS, if you look up AWS SDK, you'll see that this AWS SDK has just about everything, and that's not all the products. It's SDK for, I believe it's all inclusive for all of the AWS products, right? But that's not what we need. We all of us are going to use a certain number of those products. We use n number of them. You might use m number of them. The number varies, but regardless, it's unlikely you're using all of them. So the new version, it says you do not import that. You only import what you exactly need. So we need to make some code changes. So where we use the AWS SDK, we got rid of it, and then we started, porting it over. There was some documentation, which is inadequate, like it almost always is. So we had to play with it, figure out what those changes should be. In our latest PR, in the most recent deployment, as of the time of the recording, we have those changes in there that port our changes from previous versions of the AWS SDK version 2 to version 3. Now, AWS provides a tool to doing that. AWS SDK migrate v2 to v3. I mean, we tried that, but again, it didn't work. You can do file by file with JavaScript. We use TypeScript. I believe it's only for JavaScript. Yeah, it's SDK JavaScript code mod. It is all right. It didn't solve the problem for us. Maybe you can use it to check out what it's trying to do, but it didn't do the job. So we had to do it manually. We made those changes and then deployed it to environments to test those changes. So that took some time, because we did use AWS SDK and a lot of those higher level functions and constants and whatnot. So we had to make changes to DynamoDB dependencies as well, because we use DynamoDB as part of this gateway as one of the databases, and the way we are integrating DynamoDB had to change because of upgrading to version 3 of this SDK. So that's something we had to do. Plus, we also took the opportunity to upgrade our node versions. We were in a lower version. We went up to 22.x is the most recent one, but unfortunately it says Lambda's latest version. If you look up, it says 22.x, but it's not supported because the deployment failed. It is not something we had done wrong. It is just because there were other things, and there's open PRs there. So it's not all caught up to 22.x from what I can tell. So we just stopped short of it, and we'll probably do this upgrade at a later time to 22.x. Right now we've gone all the way up just one step below to 20.x versions, right? So we upgraded our Lambdas as well. So that's a number of things that we did here, right? Now I can close, I believe I can close these guys at this point. Now I can quickly speak to, now to be able to, deploying to Lambda takes a few minutes, right? There's, depends on how you've done it, but it can take, I don't know, up to 2 to 5 minutes sometimes. And just like, hot deploy is very important. I think I spoke to it in a different podcast altogether, in one of our podcasts. It's being able to make changes and not have to restart your servers, or making the changes as quickly as you can, as small, every few lines at a time, and verifying that it's good goes a long way in improving overall development productivity for one developer, and then as a team and as a company, essentially. So we don't want to deploy to AWS Lambda every single time to test our changes. So what we did was, there's a few different ways you can do it, but we tried a number of ways that a lot of them kind of worked but fell short. So what we did was, we added like a facade, a node, an express app that basically is something we can call without deploying, right? So instead of deploying the Lambda to AWS, when we make our code changes, add features and fix bugs and make enhancements and whatnot, we run it locally and it creates so what we can do is we can go to basically our postman and whatnot, point to 3030, because when we run this command, our server is actually running from on port 3030, and this is the request transformer. This is a yarn command that we run. When you run it, it rebuilds it, and then it's running it locally. And now when you make this request, it's not going to Lambda, it's actually going to the Express app running locally, and then it does the pass through to the Lambda section, right? At one point in the code here, Lambda comes into play. But before that, when we do the handoff, we sort of mimic that handoff and have a convenient Express app that we build, a very simple facade that does the mapping, not endpoint to endpoint, to all endpoints, sort of like a wildcard. Essentially, I think we do it by the HTTP verbs, if memory serves me right. It's on one of those deploy or local files that we can look at. Maybe it's in this local API.ts file. So that way we can make the request locally and try to get to the bottom of the problem. The thing to note is we need an API key and a product. We need the product code for sure. So the product code is specific to the product, the API, and the environment. And since we're doing this locally, we just use the dev product code. That is, like if I go search this product code, which is a dev product code in the API gateway repo, it's going to pull up a file that has all the product codes for all the environments, and you can use the one that makes the most sense for what you're working on at that point of time. Just make that change, and then the server is going to auto restart the way we've done the hot deploy configuration here for the Express app as well. So make the change. The API key, I don't believe this is you need to pass something, but not the correct one necessarily, from what I can remember, because the API key is validated by AWS when the actual legit production request is made, or request is made to one of those environments, whether it's production or lower on AWS API gateway. If the API key, which gets sent out by email, right? Once somebody subscribes to the API, I think I forgot to mention that they go to aws.snowpal.com, pick one of our APIs, and then they can hit the subscribe button. And then once they hit subscribe, you go to purchase options. It's going to show you that you can subscribe to it, and then you hit subscribe. It's going to essentially say you've subscribed to it, and it'll send the subscriber a notification that's coming from AWS, and then it'll redirect to our gateway page, which is essentially, I'm pulling it up on the local environment, but on the production version of this, where we collect information like the email and a couple other things for us to generate the API key, because the request goes from here to the API server to the gateway to an email being generated and sent to the actual subscriber. So we generate the API key, and we include the product code for the product that they subscribe to. If this fails, it means some other wiring did not work. And when the certificate had expired, that failed because the call to from the API, goes from the UI page here, UI app, to the API app, to the gateway server, and that request failed because the certificate on the gateway had expired. So the call to gateway whatever the lower environment, gateway environment.snowpal.com, failed. So that there was an error here already. There's an error here that's really bad, which means the user who wanted to subscribe to our APIs couldn't do it. That's real bad. So we had to take care of that by fixing the certificate. And once we did that, we saw the modal. You re-enter the email to confirm, to make sure you're human and whatnot. And then if it's all good, which it was after the certificate was updated, the key was generated, and you'd get an API key in the email, API key, and a product code. That's when you're actually testing the actual Lambda environment. You do need that API key, otherwise it's not going to work. So just pick one of our APIs, create a key, and use that as a key. And since it's only $2 for 1,000 requests, it's okay for us to make those tests as actual subscribers ourselves. Okay, so that is the process to get the API key. But now to test it locally, we don't need it. We just need a key, because we're calling our Express app, and there's no gateway coming into play here. So the quality of the key or the correctness of the key doesn't matter. The validity of the key, I should say, doesn't matter. But just put a value there. I think we have some test values, and we just use some key and it goes through. And now that request, given that it's a lower environment, the way it's configured is this request is going to go to the API that's running on the same machine. Now, if you want to point to the API running on a different machine, you have to kind of go update an API URL here. I forget where that is, but you can look it up on this repo. You can point to any API server. You can point to the dev server and whatnot. So you're running the Express app locally. So the Lambda changes, TypeScript code changes can be made locally and run here. But the API server that it's actually talking to is not running locally, but it's actually on our actual the production, not production, to where our API servers are running, right? Whatever environment it is, whichever environment, but where our actual servers are running, not on the dev machine. So that's how you point to it, right? So it basically goes from here, the API gateway, to the dev, to the API itself, and the API more often than not, we're just running it on the same machine. So it's quick to debug, so we can make code changes on the API too. Otherwise, we would have to deploy those changes too, right? Because surely this gateway talks to the APIs, whether it's Go APIs or Ruby APIs, it doesn't matter. One of our many APIs. Okay, so then you make this request to see if it goes through. And but before you can make, let's say if you're running this locally, the API key is not there right now. You may have the API now is running, and it could be pointing to a new database. The local API could be pointing to a new database where we actually don't have the gateway user registered. So that is something important to remember. The thing to do there is you need to onboard the customer. So if you go to one of our collections, which is the API gateway collections, and onboard customer, you can look up the body. We have some test content here. This Amazon Marketplace token is the actual legit token that would come from the AWS Marketplace to our UI gateway page, where the user would have entered those details before we generated the API key, and the product code would have been included in the email. But since this is all done locally for testing purposes, there's no code that we receive from the AWS Marketplace. So we use some expired code here. It doesn't matter. This code is only good for so long in the real world scenario. So the whole pass through of us generating the API key would need to happen in quick time. Otherwise, the code would have expired. The token that was passed to us from the AWS Marketplace to our apps UI page would have expired, and things would not have worked in the generation of the key. But in this case, we just use an old token. It does not matter if that failed, because all that we're trying to do is onboard the customer. By onboarding the customer, what it means is we create in the local server, there's a gateway user collection, and we need to enter some details in the gateway user collection. That's basically, what it is. So if you go here, this is what kind of the document looks like. So the first request, you need to onboard the customer. And once you onboard the customer, this is going to get populated with those details, as you can see here. But that does not generate the API key. You have to then call send marketplace, whatever notification here. Hang on, is that the one? No, that's not the one. Sorry, G8. Send market. No, onboard the customer. The API key I know is not created in that case when you do this, because it's going to create the document, but it's not going to populate this API key under the gateway tenant, because we need a tenant database, because we're a multi-tenant system for that particular gateway tenant. So the API key is tied to the tenant database, and then there is an AWS token here. I know that creates the document, but that does not actually create the. Let's see what this one is. Marketplace notification. No, unsubscribe. Onboard customer. Send me template records. Actually, after you onboard the customer, let's say you run this request. Let's go back to our pitch APIs and then say, register customer, and then go to the body. This needs to happen. So you come back to the other collection here, and then you make the request to register the customer, right? So the previous one here, API gateway onboard customer, this basically goes to the API, the Express app that's essentially the API gateway running locally, right? That's what we do, onboarding customer. Once that is done, we go to, the wrong one. We go to the pitch API collection and go to register customer. And this basically goes to the API server, right? Not the gateway. It goes to the API server. with this body, again, this is test. We're using this token here, probably the exact same token from we took from there. It doesn't matter. We do that, and we have to register the customer. And only when we do this is it actually going to. Oh yeah, and then we need to have the app. Hang on, we need to have the app authorization. If it's expired, we need to regenerate it locally. We have a script to regenerate it on the API, regenerate that on the API server, so it's actually valid. I don't believe we need a user auth in this case. Um, it doesn't hurt to include it, but you don't need it. I'm trying to think where the API key, because the API key is part of the gateway tenant, but I'm not seeing an API key here in the body, and its API key is not being included. Oh, we have an API key here, onboard customer. The register is AWS MP. Maybe I'm trying to think. I'm forgetting the register customer and the onboard. The onboard is what we need to do here, because if you look at the body, we have the API key, and that's what generates the tenant, because the same AWS consumer account can consume and does consume multiple Snowpal APIs. So our collection, our document here has a list here. So there's for that particular user, AWS user, they could have a number of subscriptions, and then within the subscriptions we have details about the tenant and the tenant database that we provision, because the database is completely separate for each of the customers. If they are running, if they're leveraging the API running on in our infrastructure, if they are purchasing commercial licenses to run in their own infrastructure, or we help them onboard onto that infrastructure, they could point to any database they want. So the data is entirely monitored by the end user. But in the case where we are, they choose to subscribe and pay by request or pay by subscription, monthly or annual, or by creating a private offer in AWS Marketplace, we provision, we manage their data securely, obviously on AWS through the AWS database and persistence layers and systems. But it's also multi-tenant, right? So each of their data lives separately from other customers' data, and their own data for other APIs as well. So this is the request. I don't remember the registered customer. We can try it when we do it the next time, but the onboard is what needs to be called. So the API, there is this user created in the database essentially locally. Now, once that is there, this tenant database is created and is provisioned, and you'll see that the database shows up. In this case, we don't have it because we cleaned up. So that database is going to show up, and any other requests made, right? All requests made using that API key. Like in this case, I'm doing a sign up, which is an end user request, right? After they've gotten the API, gotten access to have acquired their API key. So that all of this data is now going to live under that new tenant database that we provisioned on the API server. That's basically the wiring. You go there, you create it, and then you use that API key for every new API database. If we, let's say, start at API servers and point it to a new database either locally or on the lower environments and whatnot, we need to make sure that that mapping is in place. So that document has to have the API key and the product code that we saw earlier before you can start making those requests. Otherwise, those requests cannot be made. Now, all of this, now at this point, you can do it locally. But of course, once you provision it, you go pick the drop down here, pick one of the numerous environments, and pick the appropriate API, the correct API that you're working on, and the appropriate or the relevant environment, and then they make the request to that environment. The only difference being when you're doing it on the API gateway, you're basically going to have, I'm not going to go into the API keys and the usage plans and whatnot, but there is a notion of usage plans and API keys. So if you go to API gateway, and if you go to, for every subscriber that we would have, they would show up under API keys, whether it's us using for testing or the real production subscribers. Since these are environments that we quote unquote create, or three APIs we create to serve as environments, all the API keys across all of those environments unfortunately shows up in one place. I'm not going to click that there here because it has a list of API keys, even though they're protected and whatnot. I don't want to go there. but it has API keys for all the environments. So it's going to be a long list, and that's a little bit painful, but that's just the way it is. So even for the test user, for the test subscription that you would have just made for debugging a problem, you will see an API key. Just go get the key from there, or use the one from the email that would have been sent out, and then use it. And there's also a notion of usage plans. You can look up the marriage between usage plans and API keys, but we create those usage plans through our templates. Like in template 2, we saw a few usage plans for Blubber and Rapid API and Open API and Snowpal's internal calls. The last of them is actually free because we make our request. We don't charge ourselves, obviously. So that is a usage plan. But when it's a new subscriber, we create all of this dynamically, or use existing ones and do a mapping between the new subscription and the plans and whatnot, right? So there's a number of things that happens, but these plans that we see in these SAM Lambda files is essentially plans that we provision and create, sort of for us to get set up, right? It's part of our initial setup to deploying the Lambdas out there. But after that, at runtime, as users subscribe to the APIs, there's going to be more of these that come into play when we go into AWS and AWS console. So I think that's a fair summary of all of the pieces that come into play. I'm sure I've missed some other things here, but at least that should serve as a fair starting point for anybody who's wanting to to deploy or create apps on AWS, on API gateway, and leveraging AWS products. Now we ourselves use a number of products. I've gone through some of them here, but surely that's not a complete list, because there's a number of other dependencies that we actually do have in place that I've not mentioned in this video here. So I think that's about it. I'm going to stop sharing here. So we're gonna, if I can think of other things, then I'll probably continue sharing this. Thanks.